Okay, so my name's Colin Eberhardt. I'm CTO of Scott Logic. If you've not heard of us before, we're a UK-based software consultancy. There's around about 50,000, 200 of us. You're eating into my time, guys, please. So anyway, that's enough about us. You'll notice I'm talking about HTML5, but the real thing I want to talk to you about is developer productivity. And if you're a developer or you manage developers, you'll understand that productivity is incredibly important. If you hire a bunch of really smart guys and put them in a non-productive environment, you're wasting your money. I want to talk about the very fundamental aspect of software development, which is this, the development cycle. This is what developers do time and time again, hundreds, if not thousands of times every single day. What they do is they write some code or change some code, they build their code, then they evaluate it once the change becomes visible. And if the change is good, they go back and build something else on top of it. If it's bad, they go back and they fix it, and they iterate over and over again. The trouble is, there are a great many environments that you find yourself working in as a developer that just don't have this productive, tight cycles. So when I first started developing, I was working on desktop applications. This was back in the Visual C++ days. And this is an illustration of what would happen when I wanted to see my changes. You'd first have to compile, link, generate an executable, start the process, and it would take minutes before you got feedback on the few lines of code you'd just changed, which isn't productive. Which is why, when I first encountered web development back in the DHTML days, I was so impressed by the productivity. You'd make a change, you'd open up your browser, you'd hit F5, and bam, your change is visible immediately. And there are a number of reasons for this. JavaScript is an interpreted language. You don't have to start up a new process. It's running in the JVM. Lots and lots and lots of reasons. But it's a fantastic, productive environment. But unfortunately, we don't write DHTML little applications anymore. We write these beastly single-page applications. And I know a lot of you will be working on them now. And there's some problems with those. Firstly, you don't deliver raw JavaScript to the browser anymore. You minify it to decrease the overall payload and in some futile attempt to obfuscate and protect your IP. So you have to minify your code. Please, you're eating into my time. Well, other things you've got to do. JavaScript is an incredibly basic language. You have to add a module system. You have to add transpilers. Then there's linting, polyfills, metrics, unit tests. It goes on and on and on. All the things you've got to do to your JavaScript now. And then this probably takes a bit of explanation. Bootstrapping. This is the time between your application being visible in front of you and getting to the point you want to iterate on. So if you're working on a trade ticket, for example, and you're looking at the validation logic within the trade ticket, once you've gone through the build process, you open up your application, you have to log in, it connects to a streaming connection, you open up your trade ticket, you type in the numbers, and I've got it wrong again. And yeah, web builds now rival desktop and mobile in their complexity and duration. This is a fact. I've worked at a company where the desktop build is sort of 4 or 5 minutes, and the web build is 5 or 6 minutes. We've taken web development and we've killed it. It used to be great. It's not anymore. Marvelous. Get a drink. And that's where I want to start with my demos. It's not all bad. Things are getting a lot better, and I'm now going to be typing at arm's length with a microphone in front of me. So this is a little bit of a demonstration of the kind of applications that we work on and you find yourselves working on. So this is a fake trading application. So here you can see, we've got price tiles, we can buy and we can sell, and yeah, I can't spell. Sell obviously has 2 L's. So what I'm going to do is demonstrate how things have actually improved. So I'm going to flip over to the code, zoom in so that the people at the back can see, and there's my spelling mistake. So I'm going to change it, and normally at this point I'd hit save, it would go through the build process, my 8 minutes would be gone. It would take 5 minutes to show you the change. But now I'm just going to save it, pop back, and immediately the change is visible, which is quite interesting. This is a bit like live reload when you live reload your styles, but this is something much more fundamental here. What's happening is I'm live reloading my UI logic while maintaining my current application state, which is pretty cool. I'm going to show you another quick change. Okay, so as I'm a developer, I love to refactor, so I'm going to take my code and change it into a slightly different bit of code that does exactly the same thing, because that's refactoring. Woo. Okay, so here we go. what I've done is I've taken the text at the top and made it into a reusable component called an order tile. And here you can see, now this is a reusable component. But once again, I've broken my code because I'm that bad. So if I look here, okay, we've got base currency, which is wired up to the base currency, and we've got quote currency, which is, yeah, here's the issue. My quote currency is wired up to my base currency. So I'm going to fix that now. And this is something interesting, actually. JavaScript is not a strongly typed language. Well, JavaScript does have a type system, but it's not an extensible type system. You can't create your own types. But here, I've actually got, I've got autocomplete. Something here is giving me a type system. And that's because I'm using TypeScript, which is really cool. It's very useful in enterprise scale development. So I go back, fix my code, and yeah, it's all working now. That's really, really cool. I've now got a very productive development environment. And that's called Hot Module Reload. If you've not used it before, check it out. It allows you to do all those things. But what about state changes? What I've just demonstrated to you is a mechanism for freezing the state of your application and iterating on the user interface. The kind of applications we create are a bit more complicated than that. What if, for example, you have an issue in your validation logic and your application's moved into an incorrect state? What do you do at that point? Do you have to refresh the whole application again and wait for the whole bootstrapping? No. No, you don't. I'm going to show you something different this time. And this time, just to make it more fun, I'm going to run exactly the same application within an OpenFin container, just to prove the point that this is web technology, but it's web technology that can be used on the desktop. So here we go again, same application. This is now a desktop application. Oh, get that right. I'm going to log in. And to prove the point, what I want to do is I want to iterate on that screen that only appears for a short period of time. And normally what I'd have to do is hack the code a little bit to make sure that that screen is visible for a prolonged period of time and make some changes. But what I'm going to do now is demonstrate something really cool called time travel. And here, what I'm doing is moving my application back and forwards in time. And you can actually see the spelling mistake that I did as I typed in my password. So now, if I hold it at this particular point, go back to my code, which I can't see at arm's length, and just... So what I want to do here is that loading screen isn't terribly helpful. From a UX perspective, it would be better if I informed the user what was happening at that point in time. And that's the change I'm going to try to achieve. So if I go props, again, having autocomplete thanks to TypeScript really helps. There we go, I've saved that. And I've got live reload happening at something that occurred back in the past. So now I can go back to my time travel controls, move it forwards, and I've actually still got a fully functioning application. How cool is that? That is pretty amazing stuff. Whoa. What is happening there? My machine is going absolutely nuts. Okay, and it works on mobile too. I'm going to be really quick on this one. So here we've got an application. I'm taking a risk here because I've just taken the code off Git about half an hour ago. This is an application we haven't finished yet. It's for a local currency in the UK called the Bristol Pound. It's quite an interesting idea around cooperative currencies. This, Joe mentioned, for example, Apache Cordova. Personally, I think that's a decent technology, but React Native is something even more cool. It allows you to write JavaScript applications that render fully native UIs, so getting rid of some of the sort of usability issues you've got. And I'm just going to quickly change, and hopefully you'll see the text turning red there. And this is actually a native iOS app, which is amazing. And interestingly, the technologies here that you've seen demonstrated, one of the reasons that Facebook created React Native was the issues with building and iterating on their own mobile application. Their mobile application took 3 or 4 minutes to build. So one of their motivations for React Native was to solve that. So coming up to my conclusions, what has made this possible? Well, React, Redux, Webpack, TypeScript, Atom, OpenFin, React Native, and Chrome. So write them down and start using them. Actually, don't write them down. There's something much more fundamental going on here. If you write these down, you can screw up that piece of paper and throw it away because it will be the wrong thing next year. It will be something else. There's something much more important going on here. So I'll tell you a little story. So React was created by Facebook, which also heavily influenced Angular 2, which is a Google project. I was using Redux there, which was a community project. And Redux was adopted by Facebook. They hired the engineer behind it. I'm using Chrome, which is from Google. And Chrome, the Chromium part of Chrome is a foundation for HTML5 containers, including OpenFin, for example. Google also set the bar for developer tooling. TypeScript I'm using, which is a Microsoft project, which was also adopted by Angular 2. They were going to use a thing called AtScript, but they decided that what Microsoft had created was just as good. It fits their needs. I'm using the Atom editor, which is a GitHub project, which is the foundation of Nuclide, which is Facebook's own IDE. That rather than build their own, they decided to build on top of Atom. And Atom is built on top of Electron, which is also a GitHub project, which is itself the foundation for Visual Studio, which is a Microsoft project, which is built on top of Chromium from Google. And then there's React Native, which has been adopted by Microsoft. OK, hopefully you get the picture. This is why I like HTML5. This is why I enjoy working with HTML5. And that's because it's being pushed forwards by hundreds of enterprises, thousands of startups, and tens of thousands of individuals. This is why it's beating all the other technologies. Not because it's fundamentally better, it's because of the collective might of all these engineers from these various different companies working together and collaborating. And I guess the sort of footnote there is in the open. So many of these projects are open source, and without that open nature, we wouldn't see this amazing collaboration going on. So that's it. Time travel in the future of HTML5.